Next, we have the ether. Ethers are a little unique because they have a very traditional naming structure that is held on quite strongly. This naming structure always treated the ether constituent, both sides of it, as single carbon chains, which worked great if you don't have any complexity at all in the carbon chains. And so they would call this 1,2, 1,2, that's 2 ethyls, so it would be diethyl ether. However, this naming structure doesn't allow us to factor in any extra complexity, like if I have an aldehyde or an alcohol. It really doesn't work very well. And so we have a more modern naming structure, and we won't even be testing on this one. I'm just showing it to you because you will see it in organic chemistry, but we won't use it and we won't be testing on it. The official naming structure for an ether is picking one side of the oxygen. This is an ether. Anytime you have an oxygen bonded to both sides of it, it's going to be an ether. First, we need to pick our parent chain. The key to naming this is picking the parent chain. If both sides are the same, it's a horse apiece. Flipping the molecule around, it'll still be the same thing. So here, I can just pick either 1, 1, 2, 3. That is prop. So this will be a propane. Once I've named the propane, now I have my side chain. The ether in the official naming structure will always be treated as a side chain. So once I hit that oxygen, boom, side chain. And it will be named according to 1, 2, 3, number of carbons, just like any other side chain. But then I will give it a ending of oxy instead of ill. Where normally I would say propyl, I'm going to say propoxy. So propoxy propane would be a propane with an ether group coming off of it. And I should put a number on that as well. This is occurring on the 1 carbon, so 1 propoxy propane. Next one, I'm going to have an alcohol along with an ether. Now, which order am I going to number this in? Well, let's look at our priority to figure that out. The priority of an ether is very low, and that's because it's always treated as a side chain. It is a little more important than a halogen or a regular side chain, but not by much. We often won't get in a competition between an ether, a halogen, or a side chain. Usually if we have an ether, we're just going to have some straight carbon chains, or we're going to have some other functional groups up here. So just like I said before, the prefix is going to be the number of carbons. Just like it would be in a side chain. The suffix is going to be oxy. And so what an ether looks like is an oxygen bonded on either side to a carbon chain. If we terminated in an oxygen, that would look more like an alcohol or an aldehyde, but we are going to continue off of both sides, okay? So here we're able to name this according to the alcohol. Now clearly, the alcohol has a more complex side chain. So this side, the right side of the ether, will be our parent chain. So we're going to name it according to that. And since the alcohol does have that higher priority, I want to give the alcohol the lowest number I can. So I could either go 1, 2 or 1, 2, 3. 2 is lower, so I'm going to name this 1, 2, 3, 4, bute, and 2-ol. Here we go. And now, since that was numbered 1, 2, 3, 4, my ether is on my 4 carbon. So I'm going to call this 4, and then I need the number of carbons on this side, 1, 2. So 4, F, and then to name it as an ether, I put on the oxy. So 4-F-oxy butan 2-ol. There we go. Next one, a little more complex, but once again, I've got an aldehyde here that's going to take a higher priority, that's got greater complexity. So let's factor that in. Let's first name this. I'm going to have a 1, 2, and then I'm going to go with 3, 4 right here. 3, 4. I'm going to have a 1,2 ethyl side chain right there. And then I'm going to have a 1, 2, 3, 4 ether side chain that has a little methyl group attached to it. How am I going to be able to factor that in? That'll be a little interesting. We'll have to put that in. We'll see that in just a sec. First, let's name the aldehyde. The aldehyde is a 1, 2, 3, 4 group, so this is but-an-al. Okay. It has a 1, 2, 2 ethyl side chain. Let's just write that here. 2 ethyl. Ill. Okay. And then our ether occurs on carbon number 4. So this will normally be 4, and then 4 carbon chains long, butoxy. And then we've got this 1 methyl occurring on the 2 of the 4 butoxy. So the way we're going to do that is we're going to be able to put that name in right here as a 2 methyl. And we're going to be able to string this whole thing together using parentheses. Whenever you see parentheses in an organic name, that thing is going to be inside of whatever it's splitting up. So I've got this 4-butoxy. That means it's on the 4 carbon of its parent chain. And then in parentheses means it's on the 2 carbon of the functional group that it's sitting inside of. So let's put that all together so you can see what I'm talking about. B comes before E, so I'm going to name my ether first. Let's put a little bracket around this just so you can see the division. So 4, and then inside here, I need to put my 2-methyl. 4, then 2-methyl. Butoxy. So you see, this parentheses tells me that this functional group is actually on this functional group. I've got a functional group on a functional group. Great. Next, after butoxy, I get my 2-ethyl, and then butanal. Now I've named my ether.